Hey everyone, welcome back to the channel. Today we are diving into one of the most powerful tools in algebra, the factor theorem. This is essential for SAT, PSAT, ICSE, IGCSE and IB exams. By the end of this video, you will be able to factor any polynomial with confidence. Let's get started. If f of a equals 0, then x minus a is a factor of f of x. I can say that this is a special case of remainder theorem. It is used to find factors of polynomials. The factor theorem states for any polynomial f of x with degree n greater than or equal to 1, if f of a equals 0, then x minus a is a factor. If x minus a is a factor, then f of a is 0. Therefore, I can represent f of x equals x minus a into q of x. Now, many students get confused between the remainder theorem and the factor theorem. Let me clear this up once and for all. The remainder theorem tells us that when we divide f of x by x minus a, the remainder equals f of a. Now, the factor theorem is a special case of this. It's when the remainder equals 0, we know x minus a is a factor. This distinction is very crucial for exams. Only when the remainder is 0, then only we can say that x minus a is a factor. So I can say factor theorem is a special case of remainder theorem. Let's take an example. Let's work through this question. It says check if x minus 2 is a factor of f of x and the polynomial f of x equals x square minus 5x plus 6. We can see that it's a quadratic polynomial, and we know that whenever f of x is divided by x minus a, the remainder is f of a according to remainder theorem. But when that remainder equals 0, then we can say that x minus 2 completely divides f of x. Why did I say completely divides f of x? Because there is no remainder left when x minus 2 divides f of x. When there is no remainder left, when the remainder f of a equals 0, then I can say that x minus 2 is a factor of f of x. So all I have to do is check if the remainder f of 2 in this case is 0 or not. So if I substitute 2 in the place of x, it becomes 2 square minus 5 into 2 plus 6. That gives me 0. Since f of 2 equals 0, I can say that x minus 2 is a factor of f of x. Simple. Let's take another example. Factor completely, right? Factor completely. Now, if they give factorize f of x completely, as in this example, the first factor we need to check by trial and error. Now, I have directly substituted minus 3 here and I have checked, and I get to know that f of minus 3 gives me 0. So first you can try for 1, f of 1 you check whether it is 0 or not. If not, then you check for f of minus 1, then check for minus 2, then plus 2, then minus 3 and plus 3 and so on. So the first factor you get by trial and error. The first factor you get by trial and error. So here by trial and error, by testing, I have got x equals minus 3 as the first factor. So how do I write that factor as? I write it as x minus of minus 3, which is finally giving me x plus 3 as a factor. Now, how do you determine the other two factors? As we see this question, it's a cubic polynomial. We have got x plus 3 to be one of the factors. What about the other factor? What we do is we completely divide our polynomial by x plus 3 using synthetic division method. So when I divide this polynomial with x plus 3 using long division or synthetic division method, we get the other factor to be x square minus 6. Now I can write the complete result f of x as x plus 3 into x square minus 6. This is complete factorization. Let's take a third example. It says verify 2x plus 1 is a factor of 4x cube plus 4x square minus x minus 1. This is a typical SAT or a IB exam question. Notice the coefficient here. We have 2x plus 1, not x plus something. Don't let this throw you off. Set 2x plus 1 equal to 0. This gives me x as minus 1 by 2. Now substitute this negative 1 by 2 in the place of x. So let me consider the polynomial as f of x equals 4x cube plus 4x square minus x minus 1. Now in the place of x I'll put minus 1 by 2. That gives me f of minus 1 by 2. That would give me the result after substituting as 0 as shown here. Now because f of a is 0, because the remainder f of a is 0, I can say that x minus a is a factor. In this case I can say that it's 2x plus 1 is a factor of the given polynomial 4x cube plus 4x square minus x minus 1. Let's take another example. This involves finding an unknown. They have given that x plus 3 is a factor of x cube minus 3x square minus kx plus 24. Because x plus 3 is a factor, I know that f of minus 3 will be 0 by applying factor theorem. Now in the place of x, if I put minus 3, I should get f of minus 3 as 0 because clearly it is mentioned that x plus 3 is a factor. Hence, I can clearly find the value of k here after simplification to be 10. I hope you've understood this. This type of problem solving skill will earn you full marks on your exams. You can test simple values plus or minus 1, plus or minus 2, plus or minus 3 as I have mentioned for completely factorized type of questions. Check factors of constant term. For ax plus b, you can directly take x as minus b by a. How do you get this? By equating them to 0. Then to completely factorize, we can use synthetic division and you can verify your answer. Once you find the factor, use synthetic division to find the remaining factors, yes or no? Now, there are some common mistakes that students do. They forget to set x minus a to 0. You should always first set x minus a to 0 and find the value of x. That will be my a value that I have to substitute in the polynomial. Calculation errors with negatives. Whenever there is a negative sign, there is always a possibility of making a mistake. Because, for example, minus 1 by 2 whole to the power 3 is minus 1 by 8. Generally, students forget that minus sign. Negative number to the power of odd number is always a negative. Now, for 2x minus 1, not using x equals minus b by a can result in a mistake. Not verifying the answer can also result in an error. Now there are some key takeaways. The factor theorem states that f of a equals 0 only if x minus a is a factor. Remember, it works both ways. The factor theorem is a special case of remainder theorem when the remainder equals 0. Use the factor theorem to systematically find all the factors of a polynomial. Always test simple values as suggested before, plus or minus 1, plus or minus 2, plus or minus 3, and so on, because that saves time. And of course, practice is key. The more number of questions you practice, the more faster your calculations become, as well as you develop better accuracy. If you found this helpful, make sure to practice the problems that I've linked in the description. Thanks for watching. If this video helped you understand factor theorem, smash that like button and subscribe to the channel for more SAT, ICSE, IGCSE and IB math content. Drop your questions in the comments below. I read and respond to every single one of them. In the next video, we will cover synthetic division tricks that will blow your mind. See you there. Thank you for watching Math Fee Quest 45.